Hello, and welcome to the session on volume of prisms. What are we going to learn in this session? First, we'll understand what do we understand by volume of a 3D shape. Then we'll go on to understand the concept of unit cube and how do we use unit cube to find volume of cubes and cuboid. And finally, we'll learn how do we find volume of different prisms. So let's get started. What do we understand by volume of 3D shapes? Volume is the amount of space occupied by a 3D shape. For example, if you look at this beaker which contains water, if I were to drop this stone inside the beaker, what do you expect to happen? Well, your guess is as good as mine. If you drop the stone, the level of the water would rise, and in some cases it may even spill over depending on how big the stone is, right? Why did that happen? Because the stone is now occupied some space inside the beaker, which was originally occupied by water, because of which the space that was originally occupied by water, the water gets displaced from there, and hence the water level rises in the rest of the beaker. And if the stone was big enough, then it will rise to such a level that it might even spill over. Correct? So volume is the amount of space occupied by a 3D object. Like if you remember, when we did area was the amount of space occupied by a two-dimensional object, right? And there we understood this concept of unit square, right? Because it was two-dimensional object, it was occupying unit times unit, which is unit square. Because volume pertains to 3D object, it will have unit cube because there are three dimensions, right? Unit square and unit cube. Okay, unit cube can be millimeter cube, centimeter cube, or meter cube, depending on how big the cube is. A unit cube is a cube having each side 1 unit, right? If the dimension of each side is 1 unit, that's called a unit cube. And depending on which unit is that, millimeter, centimeter, or meter, you might have millimeter cubed, centimeter cubed, or meter cube. Now, how do we use unit cubes to find volume of prisms? Let's see. So that's 1 unit cube. What if I put 7 of them in a straight line? You would realize that there are 7 unit cubes now, and hence the volume of that shape will be 7 centimeter cube. What if I put this row 5 times besides each other, something like that? Now, how many unit cubes do you see? We have each row having 7, and there are 5 rows of that, right? There are 5 rows of 7 cubes each, which means there are 35 unit cubes. In this case, 35 centimeters cube. So the volume of that surface, okay, one layer, I would say, is 35 centimeter cube. What if I stack 4 such layers on top of each other? Well, now how many centimeter cube do I have? We had 35 in each layer, and there are 4 layers on top of each other. So it will be 35 times 4, which is 140 centimeter cube. You can see that unit cubes can be the fundamental building blocks for volume of any 3D shape. Right? Now, for instance, this is a cuboid, right? You can see that it's a cuboid having a length, a width, and a height. So how do we find volume of a cuboid? You will see that it is 7 times 5 times 4, which means volume of any cuboid will be given by length times width times height. You just have to multiply the 3 dimensions of a cuboid to find the volume of the cuboid. Well, let's try and find out volume of this cuboid, knowing that we can fit 4 unit cubes along the width, 6 along the length, and 3 along the height. So what do you think is the volume of this particular cuboid? Well, as you can see, it has width of 4, length of 6, height of 3. So the volume will be 4 times 6 times 3, which is 72 centimeter cube. So unit cube can be very useful in finding volume of 3D shapes, especially cuboid and cubes. So let's understand how do you find volume of some basic 3D shapes. Let's begin with volume of cubes and cuboids. In case of cube, all the three dimensions are the same length. So the volume of a cube is given by side times side times side, or side cubed. You just have to cube the length of each side, and that's volume of a cube. In case of a cuboid, we already saw that it's the product of all the three dimensions, which means volume will be length times width times height. Right? Let's apply this in an example. So let's say we have a cube having each side 5 centimeters. What do you think is the volume of that cube? Well, it is 5 times 5 times 5, or 5 cubed, which is 125 centimeter cube. How about volume of that cuboid having a width of 2 centimeters, length of 4 centimeters, and height of 5 centimeters? As you know, in case of a cuboid, the volume is found by multiplying all three dimensions. So it is 2 times 4 times 5, which is 40 centimeter cube. Right. Now, cube and cuboid is fine. How about volume of any prism in general? So here's how we find volume of any prism. Now, how do we classify a prism in the first place? Okay, remember what we did in classification of 3D objects? Prisms are 3D shapes where the cross section remains the same throughout along one dimension. So in this case, it's a hexagonal based prism. So the cross section is a hexagon. So to find the volume of a prism, all we need to do is find the area of the base, multiply it by the height, because we are stacking that base one on top of each other, right? All the way till the top. So you find area of the base, multiply it by the height, and you get volume of any prism. Please remember this formula. For any prism, volume is given by area of the base multiplied by the height. For example, let's try and calculate volume of this triangular based prism. Now, area of the base. Is the base the face on which it is resting? The rectangular one? No. Okay, please remember that. The base of any prism is the cross section that remains same throughout. In this case, it is the triangle, right? The triangle is the cross section which remains same throughout that dimension, which is the length. So the base of the prism is the triangle, having the base as 4 centimeters, and the height of the triangle is 6 centimeters. How do you find area of a triangle? Area of the triangle is base times height divided by 2. So in this case, it would be 4 times 6 divided by 2. That's the area of the triangle, which is the base of the prism. And the height of the prism is the dimension, which is 12 centimeters long, because along that dimension, the triangular base is the same cross section, right? So we multiply the area of the base by the height of the prism, which is 12 centimeters, right? So the final answer would then be 144 centimeter cube. So remember this, for any prism, volume is given by area of the cross section multiplied by height. Well, there are two more prisms here. Let's try and calculate the volume of each of these prisms. Let's begin with the one on the left. What do you think is the cross section of that prism? It is triangle again, right? Because the front face, which is triangular, remains the same throughout, correct? So we need to find the area of that particular triangle, which is base of 12 and height of 16, as you can see. So it's 16 times 12 divided by 2. And the height of the prism will be the dimension, which is 10 centimeters long, right? So you multiply area of the base, which is 96 centimeters squared, by the height, which is 10 centimeters. And hence, the volume of that prism would be 960 centimeter cube. How about volume of the prism on the right? What's the cross section of that prism? As you can see clearly, the cross section of that prism is the trapezium, right? Because that cross section remains the same throughout the dimension, which is 35 meters long. So we need to find the area of the trapezium and multiply it by 35 to get the volume of that prism. Now, how do we find area of trapezium? Area for trapezium is addition of the parallel sides multiplied by the height divided by 2, right? So let's first find the area of the trapezium. It's addition or the sum of parallel sides, which is 13 and 17. So 13 plus 17, multiply it by the height, which is the distance between the parallel sides, which is 6, divide by 2, which is 90 meters squared. Well, that's the area of the base. What's the height of the prism? It is the dimension which is going from front to back, which is 35 meters long. That's the height of the prism. So your final answer for volume will be 90, which is area of the prism, area of the base, multiplied by the height of the prism, which is 35. And that's 3,150 meter cube, right? So once you know the formula for finding area of a prism, finding area of any prism is fairly simple. All you need to do is find the area of the base and multiply it by the height, right? Well, that brings us to the assignment for this session. If you look at each of these questions, okay, we have divided them into or grouped them into different prisms. The first two questions are pertaining to cube. The next 8 questions are pertaining to cuboid. Then 11, 12, and 13 are triangular prisms. And the challenge questions 14 and 15 are trapezium based prisms. Now that you know how to find the volume of the prism, you can find volume of each of them fairly easily, right? Well, that's the end of today's session. Let's recap what we learned in this session. We first understood what is volume of any prism. Volume of any prism is the amount of space occupied by any 3D shape or any prism. Then we understood the concept of unit cube and how that concept of unit cube can be used to find volume of cubes or cuboids. And finally, we went on to see a formula by which we can find volume of any prism. Remember, the formula was area of the base multiplied by height. Well, I hope you understood the concepts learned in this lesson. Thanks a lot.